velocity ratio, slip in belt, grip and slip of belt, maintenance feature of the Vee belt, belt tension, adjustment of tension, arc of contact, belt efficiency, measure the tension of Vee belt drives, and care and maintenance. So these are related all belt drives. Okay. पहिले आम्ही त्याची बेसिक थिअरी शिकले कल कल बेल्ट असतात त्याचे एलिमेंट शिकले सगळं झालं नाव वी विल सी the advantages and disadvantages of Vee belt, velocity ratio and everything. So first, advantages and disadvantages of Vee belt. So Vee belt drive, there is a Vee group pulley drive, then there is a Vee belt, you can say trapezoidal cross section, and these belts are classified in the A, B, C section. Okay, based on the width groove, no, the sections are different, and normally no belt number is given as per the circumference length. From this pulley to that pulley, how much total distance is it? Circumference length, that and section, the numbers are designed to the belt given. The first basic advantage, first is high velocity ratio up to 7 and even 10. So velocity ratio can be 7 and even 10. Possibility of employment with small center distance. There are some small center distance also can be possible. For flat belt drive, a minimum center distance recommended is 2 plus T plus T. This is the one general formula they are given. From this pulley to that, don't talk. Flat belt drive, the minimum center distance considered as, this is the case of flat belt drive. Recommended as C is equal to 2 times capital D plus small d. जो दोनों diameter pulley just above, it has to be double. Suppose this is 100, this is 200, both will be 300. 300, it has to be double, means 600, that should be a length. So now we can go further. This is the general formula precaution purpose. You should know kitna distance. Then for Vee belt drive, this is in the case of flat belt drive. Suppose Vee belt drive same, the center between the pulley should be what? How much distance? Minimum. It should be 0.55 D plus T plus T, where T is the height of the belt section. So 0.55 means whatever distance you are getting from D plus T, it has to be multiplied to 0.5. Means suppose 200, otherwise it should be a half almost. 99.5 something, you have got 98.5 something. Plus you have to give the T, that is a height of the belt section. The belt section, Vee belt section, A, B, C, with height of suppose, it add that should be a minimum distance between the two things. Reliability of the belt drive in any position, even with a vertical shaft. So reliability of the drive is any position, even with a vertical shaft. Smoothness of operation owing to the obvious of less joints and other belt fasteners. So these are the all advantages of this belt drive. So smoothness of the operation owing the absence of less joint other than belt fasteners. So most of the Vee belt they don't have a belt joint in between. Although I take the power, mostly there is no joints. Full one belt and you can check with the Vee belt. This is one advantage. Even with the vertical shaft also. Now there are some disadvantages also there in this belt. These advantages, Vee belts are not durable as flat ones because of the high bending stress. Most of the Vee belt are the third time durable, and after some period of time it has to be replaced. Wear and tear normal attack. There is one disadvantage. Second, this is due to the fact that ratio of belt section height to the pulley diameter is considerably higher than the flat belt. So the ratio of the belt section cross section, height, length, width, belt section height to the pulley diameter is considerably higher than the flat belt. So flat belt height. Second, disadvantage, design of Vee belt diversion is more complicated than that of flat belt. So this is also we can accept. The design of the Vee Belt Drive, we have to design the V group pulley, Vee belt. The design is a little bit complicated compared to the flat belt. Flat means direct rectangle piece flat galo like much time with it. Vee belt drives cannot be used for large capacity center distance. So pose is the Vee belt we cannot use. Efficiency of Vee belt drive is somewhat lower than its electric grip is somewhat higher than that flat belt. So most of these Vee belts get grip. Bitter much they grip देता है. Gas get उड़ता. Sometimes gas get उड़की the pulley will move without taking the driven pulley. ते का मी ते grip म्हणता. कुछ घासता मुखात परत flexible जाता. Straight जाता. That is grip. And slip मिळाला ते gain असतो ते slip. We'll see that in the next. एक तो एक point दे देतो. Velocity ratio. Now this is a calculation point. You should know how you can calculate the velocity ratio. Velocity ratio actually from one driver pulley to driven pulley, how much rotation is to cover. ये चार पार्ट गुजरा तीन दो पार्ट गुपा जाए. So there are called velocity ratio. Velocity ratio defined as the ratio of speed of the driven to the speed of the driver. Right? Speed of the driven to the speed of the driver. Driven and driver खबरा मानूंगा. So here driven is what follower. Driven and follower is same. And driver is connected to the prime mover or motor. Which motor is called prime mover. Generally it's connected to the motor. So this is a driver. So it is a velocity ratio defined as ratio of speed of driven to the speed of the driver. Understood, no? Driven what only pull that ratio to this. So bigger upon smaller or whatever. Driver could identify driven to the speed of the driver. Hence, velocity ratio is equal to n2 upon n1. Understood why n1 upon n2 के अंदर because of the driven first. It's a ratio of driven upon driver. Therefore, n1 is a driver, n2 is a driven. Whenever it's given. So the velocity ratio how you compare that expression? It's a ratio of driven pulley to the driver. So this n2 upon driven. So suppose if in any calculation point we have given the velocity ratio. So if I get we need to find out the input this into the equation. The velocity in terms of diameter of pulley are the same in terms of diameter of pulley. Actually, when we work in the diameter of pulley is diameter class velocity ratio. This is required to be calculated. See, in a belt drive, the velocity of the belt is constant to the driver and driven. It has to come driver and driven. So belt, but velocity of the belt is given by V is equal to R into omega. Okay. Given like this. So that is equal to d by 2. So 2 pi n upon 60, so omega's angular velocity. 2 pi n upon 60, hence d1 by d2 multiply to 2 pi n1 upon 60, so d2 by d2 by 2 into 2 pi n2 upon 16. This is for the both pulleys. A combined column, we will get one equation that this is very important. So if you multiply this, we can keep some common. Velocity ratio is equal to n2 upon n1, that is equal to d1 upon d2. Just you have to remember this in your life. The velocity ratio is equal to n2 upon n1, that is equal to same, that is equal to d1 upon d2. The time value calculation. What is it? Yeah, now suppose ये करता है आगे करता है डायरेक्ट करता है लोगों में तो एक डायरेक्ट we can find out. When the thickness of the belt is considered, then velocity ratio is equal to n2 upon n1 is equal to d1 upon d2 plus t plus t. If the thickness of the belt is given, then you have to add the thickness of the belt with the diameter. So d1 is the diameter of the driver pulley, d2 is the diameter of driven pulley, n1 is the speed of driver pulley, n2 is the speed of driven pulley, and t is the thickness of the belt. So just remember, एक stand n कटा करना n2 रहता because of the driven. Because velocity is defined as per like this, and in terms of diameter, it is direct d1 upon d2. बराबर है कि चलते हैं. It is little bit calculation part. अगर तुमका there is no big calculation, small calculation you can remember. Now sleep in the bed. So what is a sleep? Sleep क्या रहता? हम sleep में डाले क्या नहीं actually? Generally sleep like that. Now this is a driver pulley and there is a driven pulley. So driver pulley rotates, and same time the driven pulley has to be also rotate. No? Suddenly, what happens? The belt is just pass without carrying the driven pulley. Pulley guna to belt also that is slip actually. Okay, this it has to be transmit the power. The torque in some guna. If the belt is rotated without taking the torque, without rotating the other pulleys, then it's slip. Right? So power will be get lost over. So this in the belt, this study has to be done. Okay. So relative motion between the belt and the pulley is called slip. Understood? Relative motion between the belt and pulley. So when the belt is passing to this flow, no, there is a relative motion. Suddenly push along without taking the pulley, it's a slip. Relative motion between the belt and the pulley is called slip. Slip is measured by difference in the linear speed of the pulley, rim, and the belt. You can measure also. And the slip may be occurred both at driver and driven. This can be occur at both, either on the driver pulley or on the driven pulley also. Anyway, effect of the slip. At the slip due to the slip, the velocity ratio in the belt drive cannot be maintained constant, and also it result loss of power. After slip the velocity ratio to the design will not get. Okay, there will loss in the velocity ratio. Maintain the constant. Also, it will result in loss in the power. Then considering the slip in the belt, velocity ratio is given by, if there is a, suppose you have to consider slip, then we can mention the velocity ratio formula like this. N2 upon N1 D1 by D2 plus thickness of the belt, that is going to multiply to 1 minus whatever the slip is given, 1%, 2%. So divided by 100. No? So that slip you have to keep it here, divided by 100. That is the minus. So diameter of the driven pulley, D2 is diameter of the driver pulley, then driven pulley, N1 speed of the driver pulley, N2 speed of the driven pulley, and the total percentage of slip between the driver and the driven is equal to S1 plus S2. and the S1 is equal to percent of slip at driver, S2 is percent of slip at driver. Okay, so for total delay, you have to take both this plus and put it in this formula. In the case the slip is given. So slip म्हणजे काय क्लियर झालं now creep म्हणजे किती creep and slip of the bed. Mostly creep केला जाता. You can see this picture here. Okay, this is the driver pulley. This is takes the belt like this and throw it out here, and this becomes slack side. Now what happens? Arc of the contact, you can say C. From here to here, there is an angle of contact of the belt on the pulley. Creep begin here. आता एक second creep form जाता. Actually, creep म्हणजे किती जाणं? As the belt turns on the pulley, it tends to stretch on the contact area of the driving pulley and shorten on the driven pulley. So, वो belt असा जर तो pass जाता, creep समज झालेला वो belt जाता एक stretch जाता. Stretch म्हणजे घास घेऊन उडता, मध्ये सुट्टा. कळलं? Compress जाता, मध्ये जाता, आणि तो त्याची effect जाता. It stretch on the contact area. कितल्या पैकी stretch जाता. असं लांब stretch जाता आणि मध्ये सुट्टा. That is creep. See, the belt turn on the pulley it tends to stretch on the contact area of driving pulley and shorten on the driven pulley. So, इन्हें तो last के तो मैं think दूसरे तो think में short पट्टा. चला इनका एक side tight और एक side यहाँ तो लूज जाता है उसके जाता है. Shorten in the driven pulley. So this localized movement of the belt is directed result of the elastic stretch and is known as a creep. So suddenly stretch जाता, मध्ये में सुट्टा, so elastic जाता, elastic कशा आपण elastic जाता. That process is called creep. Understood, no? The greater the load, more will be creep. Absurd load झाला, this time has happened. मी घास करता मुका जाता. So it's overloaded. Any machines, if hopper is overloaded, then this type of problems are happen. The figure shows the condition of the belt as a result of slip. The slip is the actual difference caused between the surface speed of the belt and the pulley